have a presentation from one of our sponsors, company Roslesinforg. Mr. A.Bukas, Deputy Department Director on Forest Inventory.
Good afternoon, distinguished colleagues. I represent here one of the largest enterprises doing all sorts of forest accounting activities, and the main activity that we perform is the state inventory of Russian forests, which is doing strategic tasks on management of forests located over the regional level, and which this level is developing and is actively using the remote sensing data. Besides, we have a number of other activities that we perform: forest management, forest registry, forest cadastre activities. These types of work are done by our enterprise, and we use space imagery for that. But today I'm going to speak only about the state inventory of Russian forests. The main purpose of state inventory of forests, as identified by the Forest Code of Russia, is the timely detection and the forecasting of the process development which can have negative impact on forest, efficiency assessment on protection and reproduction of forests, and information support on the management, use, protection of forests. Out of the full activities performed by the within the state inventory of forests, space imagery is actively used in two activities: when we identify the status of forests, their qualitative and quantitative characteristics, and when doing the work on remote monitoring of forests. These are the two largest activities performed by the state inventory, the most labor-intensive ones. As you can see from the information on this slide, the object of our work in the first case is the whole territory of Russia, wooded areas of Russia, and we have a total of 34 of them, and other regions of Russia. When doing the remote sensing, remote monitoring, then we work with particular forestry departments. When doing the work on identifying the qualitative and quantitative characteristics, we use landscape approach, which combines remote and land-based methods. We plan works in accordance with the Forestry Development Program, which was adopted by the Russian Federation until the period of 2020. The technical foundation of identifying the qualitative and quantitative characteristics is the materials of space images with the resolution of no less than 5 meters, topographic maps, and land use materials. The reports on this sector are provided regularly throughout the year, and the final report is provided upon the completion of the work. In this case, it would be for either region of Russia or any forestry department. When doing remote monitoring of forest use, we apply mostly remote methods, and land-based method is used for only verification of remote methods, and we have plans for works also in accordance with the approved forest development program of Russia. The technical basis for us are the materials of space imagery with a resolution no less than 5 meters, and land use materials. This is more operational work. We do operational reporting on the weekly basis. We submit to executive authorities of both regional and federal authorities all the materials on detected violations, and with the proper detection of those localities. When identifying qualitative and quantitative characteristics of forests, the materials of space imagery are used in two ways. First, creation and updating of the digital mapping basis and clarification of boundaries of and contours of forests when there are no proper land use materials in place. This is quite a big amount of information which we need to analyze based on the space imagery. In 2012 we have done some analysis on this, and the total area of changes was 8+ million hectares out of more than 60 million hectares. At the same time, the number of contours was more than 200,000 new ones. Here you can see a brief description so that you can have a more or less accurate picture about the volume of our work and dynamics of our work. You can see that throughout the period of state inventory of forests, starting from 2007, in other words, when we introduced a new forestry code, the overall area of work for qualitative and quantitative characteristics is more than 200 million hectares, and we have already more than 30,000 test sites out of 80,000, almost half of them. This slide shows what images and what percentage and with what resolution is used when doing our projects on introducing changes into the maps and schematics which are prepared after the state inventory forests. Unfortunately, in 2013, the work is still in progress on detection and creation of such maps. We provide statistics for 2012 here only. The overall area and the volume of work that we did in 2012 covered the area of more than 60 million hectares, and we covered by highly detailed imagery most of the sites in this area. 98% was the acquisition with the resolution of 2.5 meters and higher. For you to better understand how we used those materials, here you can see a brief schematic. It is based on the materials of forest use, topographic maps. Then we developed a digital base map, and which is then updated, and then it is based on the materials of space imagery. The digital updated base is then updated also, and we can see an updated information which shows the exact areas of forest plots. So this is the technological scheme of using the materials of remote sensing data during the state inventory of forests. The second direction where we use the materials of space imagery is the remote monitoring of forest use. The space images in these projects are used for contour interpretation of forest plots and for analytical interpretation of forestry divisions, and we identify areas which are illegally used by violators. Throughout the remote monitoring existence, and our work on the remote monitoring started in 2005. It was the work on the detection of illegal timber logging, and then our remote monitoring became part of the state inventory effort on the annual basis until 2012. We were upgrading the number of Russian subjects where such work is done. Mostly there were zones of intensive use of forests for the purpose of timber logging. For your information, you can see how many sizes, how many plots were observed by us throughout that period. That would be 3,000 sites like that. With this kind of work, we use also highly detailed images. More than 98% of all images have the resolution of 2 meters or better. So virtually we can detect quite clearly all the sites of illegal logging and the sites which are used according to the official permits. Also, we don't show the information 2013 because the state contract hasn't been completed yet on remote monitoring. That's why we have statistics only for 2012. Here on this slide you can see a brief schematic description of how we use the remote sensing data. Here we see the multi-temporal composite made of 2 images. In this case, that will be the space images of 2010-2012, using multi-temporal composite and materials which we acquire from the executive authorities. We can evaluate how correctly the land plots were alienated. In this case, we're talking about logging areas, and red color denotes the area of logging which was done illegally. As a result of this work, we prepare a special document, the so-called interpretation certificate, and we send it to the executive authorities of the Russian Federation. In this way, we detect and send this information about illegal violations in forests, and we notify proper authorities about it. The life is not standing still. That is why all the activities of state inventory of forests require further improvement. That's what the President of Russia was talking about at his meetings on the development of forestry, and the most recent instruction of the President stipulate that we need to increase the efficiency of state inventory of forests. This work at our enterprise is done on a continuous basis since we received our first contract, the first state contract on state inventory of forests. We constantly, on a yearly basis, improve or add, augment something. Out of most recent developments, I can mention that now we're especially interested on using the materials of space imagery acquired by Russian satellites. This approach will help us, we believe, to reduce the prime cost of this work in terms of identification, qualitative and quantitative characteristics, and from also because the remote sensing data, as stated by our operators, are no worse than the ones acquired or bought currently from foreign suppliers. Now we're studying the possibility of using our satellites Canopus and Resource P for state inventory forests, and we're considering a few days are left for final decision. Actually, now we already have a draft agreement between the Roscosmos and the Russian Forestry Ministry to use these materials for state inventory of forests. Russian Roslesinforg will be authorized to use this remote sensing data to implement its work under state contracts. Now we have acquired some of the materials already, and we are studying the possibility of using these materials, as long as everybody understands, of course, that there are some specifics of using materials or images from other satellites. The main problem that we are encountering at the moment when using materials of remote sensing data generated by Russian satellites, of course, the relatively small coverage of the territories that are of special interest for us. Now we have completed the work in many regions of Russia, 13 regions, which are located in central Russia, in north, west, and south. Next, our vector is moving to northeast, where the materials of remote sensing data will be of special importance and high demand, and I don't think we'll be able to do anything without them. And the overall areas are quite vast there, and that's why the use of Russian satellites will help us to reduce the costliness of this endeavor. On this slide, you can see those Russian satellites which we're considering at the moment as our prospects for the future. Canopus and Resource B are going to be tested very soon. They're going to be tested by our enterprise. Also, we are looking at Obzor R. I'm going to tell you more about it, about how we are going to use the radar images for state inventory of forests. As long as we still don't have enough coverage from Russian satellites, we're also following the advent of foreign satellites and image providers. And here you can see foreign satellites that are of special interest for state inventory of forests in Russia, and which we consider as a possibility for the future, but still will make the decision in favor of Russian satellites because of the reasons that I have outlined already. As far as our satellite Obzor is concerned, and in general about the use of radar imagery, radar and multispectral imagery, for what purposes can we use it? Improvement of the accuracy of parameters of forest disruption and better accuracy in determining the boundaries of forests, especially in the areas where there are no good plans or topographic maps. And thirdly, it would be especially useful during image acquisition in cloudy areas. Radar imagery, it was already mentioned today by somebody from the representative of Scanex, when they were asked how to fight cloudiness. There is no way to fight it, because if there were summer like this year, you simply have to cut away big sections from them, and then you make composites out of this patchwork. The only way out is to use radar images. To use them, we need to study what capacities exist for the purposes which we pursue in the state inventory of forests. Secondly, second thing that we would like to develop at our enterprise and implement it later on is the remote monitoring of random tree cutting. We sometimes study those areas which had been, we mostly study only those areas which had an all-out tree cutting, when a whole section or plot had been cut down. But we have whole federal regions, like in the southern federal region, where all the forests are considered to be protected, and the tree cutting is done on the more ad hoc basis. And in the far east of Russia, we also do a lot of ad hoc cutting, and to control this ad hoc cutting is very difficult from space, because there is no good, well-tested technology on how to do that, and it's very difficult to use some kind of imagery to control and detect this type of forest use. As a result, going back to the first two directions of the development and improvement of the state inventory of forests, Roslesinforg and Sovzond have struck an agreement within which we'll be doing some experimental work, which will help us to study the possibility of detecting ad hoc cutting using radar images, and then possibility of proper forest classification, again based on radar and multispectral imagery. This work or experiment is done on one of the forestry departments of the Vologod region. The main purpose of this work is application of the acquired technology of remote monitoring of forest use using radar space imaging and the application of taxation methods based on the results of joint processing of radar and optical multispectral data. At the moment, this project is not over yet. A lot of activities have been completed, though, and we expect that upon conclusion of this experimental project will generate thematic maps based on radar images and multispectral images. We still want to see what can be acquired if we use such data under the clouded conditions. And as part of this pilot project, we'll do some training for the people on how to interpret radar space imagery. Many of the sites and many of the thematic maps already have composites, and we have images acquired for them. We have plans for October to complete and get a report on the implementation of this pilot work. These data are going to be well verified. Until the beginning of this work, we put down 90 GCPs or ground control points using the highly precise exact tools which are used for identification of qualitative and quantitative characteristics on the reference sites. And we believe that the result will be good and a well verifiable one as well. I'll tell you another story about yet another project that we completed in the Krasnoyarsk region. You might have seen that in the remote monitoring forests, we evaluate and assess forest cutting areas of the previous year, which is not really timely in terms of identification and reaction to such possible violations. As a result, we have done some experimental work on operational remote monitoring of forests, and people from the executive authorities of Krasnoyarsk region were involved, and the Engineering Technological Center SCANEX, and our branch of a BEST project, and we organized it on the Gremuchino Forestry Department on 150,000 hectares. As long as I don't have much time left, maybe I'll skip a number of slides and move to the conclusions right away about the capacities of remote monitoring. When doing operational remote monitoring, the time for this work has been reduced by a whole year. We have increased and enhanced the sophistication of this interpretation, especially during spring and autumn times. We have increased the overall volume of interpretation, and we had more supplies from space imagery. We realized that we need to introduce an electronic documentation system to increase timeliness and to find a solution for the image delivery if we want to use this remote monitoring on more timely basis. Thank you for your attention. I'll answer your questions if you have them. Are there any questions? If there are no questions, then we have one very small, very brief intervention. Thank you. Again, people from Scanex